Hey there, sixth graders. We're going to go ahead and take a look at what we call measures of variation, which is a different set of statistical descriptors or descriptions of our data sets. And what measures of variation describe is that they describe the distribution or spread of our data. So the last lesson we learned about measures of center, which described the middle of our data sets, but now we're going to measure how widely spread our data sets are, because some of them are going to be super clumped together and others, as we're going to see, could be super spaced out. So we have a couple of different terms that do describe the spread of our data, and the most popular one is what we call the range. And the range of the data describes how spread out the data is. And the way we calculate it is really what we're measuring is the distance from the lowest piece of data to the greatest piece of data. So we are going to be finding just kind of what is that range, what is that distance between that smallest point and the biggest point. And so we're going to use subtraction, because when we find the distance between any two things mathematically, what we're doing is we are subtracting. So this is a very simple equation to compute the range, and we are just going to take our biggest point, the maximum, and we're going to subtract the minimum away from it. So let's find the range of the following data sets. So all we need to do is find the biggest point, find the smallest point, and subtract. So let's see, my maximum is right here. So that's my max. My minimum is 4. So I want to know how spread out this data is. So my range is going to be 82 minus 4, which is 78. So this means that my data is spread out over the course of 78 units. And let's say this was like inches, we were measuring stuff, or let's say this is like percent, because these are test grades. So the range of the test grades would be the range spreads out over 78%, or if we were talking about inches, this would be the data would spread over 78 inches. So yeah, whatever your units are, that's what your range would also have as well. So let's find the range here. Our range, again, very simply, we're going to take the biggest number and subtract the smallest one. It's looking like 495 is my biggest. Let's see, 52 is my smallest. So 495 minus 52. And let's see, what do we get here? We get 3 in the ones column, 4 in the tens column, and 4 in the hundreds column. So our range is 443. So let's compare these two ranges. The range of this is 78, but the range of this is 443, which means this one is obviously more spread out. It just tells us how spread out our data is. All right, let's talk about a thing called quartiles. Now, this is where it gets a little bit more complicated, but if we use our knowledge of stems and the meanings of quarts, this is very easy to understand. So a quartile, as you can assume or predict, is when we're breaking up our data into 4 equal parts, because quarts means 4. So we're going to break up our data into quartiles first by finding the median or the middle. Then what we're going to do is we're going to find the median of the first half of data. That's called the first quartile. Then what we're going to do is we're going to find the median of the second half of data, and that's called the third quartile. Okay, I'm going to do an example to help make sense out of this, and I think visually you're going to understand pretty quickly. I just have to go through an example first. So what we're going to do, in order to even find the median, remember, we need to order from least to greatest first. Okay, so we need to order from least to greatest first. Let's go ahead and do that. So my lowest point is 14. Let's see what's next. 18. 20. 25. 26. So 20, 25, 26. 29. And 37. So again, literally what I'm going to be doing is I'm going to be breaking this up into 4 equal groups, and there's a very strategic way to do this. The first thing I'm going to do, just like when you found a quarter of anything, when I used to give you, for example, let's get a visual here. If I gave you a block and I told you to break it up in quarters, the first thing you would do is cut it in half. And then you cut your halves in half. Well, guess what? That first half that you just cut, that's your median, which is also going to be called our second quartile, Q2, or second, or sorry, sub, Q sub 2. Then we broke our first half in half, and that gave us our first quartile. That's the first quarter. And then this is the third quarter, and technically at the end it would be the fourth quartile, or one whole thing. So what we're going to do next is we are going to find, let me use a pencil here. What we're going to do next is we're going to find the median. So I'm going to work my way in. Boop, 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 boop. So here's my median. So this is technically my second quartile. So my median is 25. So now what I'm going to do is I'm going to look at this first half of data. And now I'm going to break that in half. So I'm going to find the median of this. So I cross these out, boop, boop, and I get 18. That's my first quartile. And then I'm going to look at the second half of data. And I'm going to find the median of this, boop, boop, 29. So literally, if you can see, and I'll go ahead and highlight this, I have just broken up my data into 4 equal groups, and these were the dividers. So this is the first 25% of our data. This is the second 25%, the third 25%, and the last quarter of the data. So our first quartile was 18, and our third quartile was 29. Okay, let's see what happens when we get an even set of data. So again, let's order this from least to greatest. Let's see, 1, 3, 4, 5, 8, 9, 10, 15. Okay, I like to cross them out to make sure I've gotten every single number. So let's go ahead and start crossing these out to find our median. So we're going to cut it in half, and then we're going to cut our halves in half. So, okay, so I have these two, which means my median is going to be right in the middle. Let's see. So to find the median of that, I'm going to do 5 plus 8 divided by 2. That's 13 divided by 2, which is 6.5. So my median is 6.5, or that's what I can also call my second quartile, okay? And let's go ahead and take a look at this first half of data. So I'm going to look at this entire first half, and then this is my entire second half. I'm not going to include the median here. Now I'm going to go ahead and find the median of this. So boom, boom. I need to find the middle of these two. Well, I know that 3 plus 4 is 7 divided by 2 is 3.5. So that's my first quartile is 3.5. And then lastly, I'm going to look at this last half here. Cross those out. 9 and 10. What's halfway between 9 and 10? 9.5. So my third quartile is 9.5. And again, in pink, I'm going to go ahead and kind of highlight these 4 equal groups. I've just created 4 equal groups of 2 pieces of data. So if you scored, let's say this was like, I don't know, whatever you really want it to be. I mean, it could be how high you can jump, 1 inch, 3 inches, 4 inches, 5 inches, 8 inches, 9 inches, 10 inches, 15 inches. If you can jump 10 inches, compared to everybody else, you are in the top 75%. So you are in the last quartile, which means that you beat 75% of the people who were in this jumping contest. If you jumped 4 inches, then you're in that second quartile, which means you did better than 25%, because really what this represents is 25% of your data. So if I look here, so this is 25% of the data. Here's another 25%, which means everything behind the second quartile, that's 50% of your data. It's half the data. Here is 25% of your data, and here is 25% of your data. All right, let's go ahead and take a look. Let's do something with this information, because we have another descriptor for our data, and it's called the interquartile range. And it is the distance, because that's what range means. Range is distance. So this literally translates to be the distance between, inter means between, the quartiles. It is the distance between the first quartile and the third quartile. And that is your formula right there. It's the third quartile minus the first quartile. And again, the STEM inter means between. And if you think about like international flights, those are flights that are between countries because you have the STEM international. So interquartile means the distance between the quartiles. So if we go back to these examples, and I'll kind of stack the papers here as best I can. Oh, let me slide down. Yeah, I'll just kind of refer back to it. So our IQR, our interquartile range for the first example on the front, well, my Q1, my Q3 was 29. My Q1, my first quartile was 18. So we're going to subtract, and the interquartile range is 11. So that kind of just narrows down how spaced out your data is. And for the second one, my interquartile range, my first quartile was 9.5. My first quartile was 3.5. I subtract those, and I get 6 was my interquartile range. And then we have things called outliers, and these are actually pretty important to identify because outliers can really kind of mess up your data set. It's still a perfectly valid piece of information, but sometimes we have to change our decisions based on whether a piece of data is an outlier or not. And I think you'll understand what I mean in a moment. So outliers are kind of just like they sound. They're pieces of data that just like are way out there. They're like super outliers. They're out there. They're loners. They are significantly less than or greater than the rest of the data. They just stick out like a sore thumb. So if we